And we're live. Okay. Hello all, hello world. This is day 102, I think. I hope I got the number correct. Of studying compilers every day until I land a compiler role. Finally, for the first time in a couple days, I've been able to have a relatively chill day. So, got a lot done, including getting my hair re-dyed. So, it's quite purple. It's quite deep. But yeah, we get to, I guess, write more code, which is always the best part of every day. Yeah, so last time, what did I do last time actually? I guess I should git log. Okay, we did a little bit of refactoring. Oh, we added like proper stack variable accesses for loads and stores. Proper in air quotes. There might be some issues that I hadn't foreseen with that will come up and definitely won't cause me any issues in the future. But yeah, that's what we did last time. Luckily, I think this means I finally run out of things to, I guess, stall doing tree tiling with. So yeah, I think it's finally time to, I guess, start doing tree tiling properly. After this point, we should have instruction selection just complete straight up. So yeah, I'm quite excited to see what happens with that. So I guess we can just get into it now. What did I do with my lighting? Let me fix something. Okay, lighting fixed. Okay. So yeah. If we build and if we make tests, they'll still do exactly what we expected them to do. We skipped the ones that we don't have anything for. So, yeah. I guess we can start staring at the backend slush again. Yeah. So I guess we can kind of just look inside this tile trees function. Or I guess class file, yeah. Yeah, so this is all quite sloppy, and this was like my first attempt at, I guess, re-diagramming this. I've since realized this is a little bit troll, so we're gonna avoid doing it this way. And full disclosure, I took a bit of time off stream to, I guess, just look at the previous implementation I've done of a tree tiling sort of algorithm. This was for the compilers class that I took roughly 2 years ago. The code was very poorly written for various different reasons, and if you want to see an example of why, you should join the Discord. It's in the description. There's a wonderful snippet of code in the compilers channel. Yeah, so we're going to pretty much re-implement that, but in a less ugly way. And I guess this all starts with a header. So this tree tiler object is still fine. I think most of this is still pretty usable. I'm trying to think what the best way to go about this is. I think I should make a... Actually no, this is fine. I should get rid of these two though. I think this is sufficient for, I guess, tree tiling. At least like the object that does the tiling. And then aside from this, I'm going to add a tile class. And that will, I think that is the big missing piece in the way I was thinking about this. I'm also going to need to add like enum values to the nodes, but that's like a speed optimization for later. I could probably get lazy and just like do dynamic cast for now and just get a very minimal tiling set going. Yeah. So I guess, what does my tile need? My tile class. I guess this is easier to define once we, I guess, start working on tile again. So I guess we can start with this for now. And we're kind of back to where we began with all of this, but it is what it is. I Okay, so we should keep this assembly node thing at the top. If we're confident enough, why not just cash in on bug bounties instead of wasting time on job? That's a good question. I don't think there's bug bounty stuff for compilers for the most part. Or at least like it probably exists, but I don't know. It seems like a lot more work at least. And I also feel like part of the value, or I guess like part of why I want a compiler job is because like I feel like I guess there's more of an environment of just like other people that share similar goals that I can, I guess, interact with on a semi-frequent basis, and it would just be like, it'd be like way cooler, I think, at least. It's not very concrete. I haven't like thought about it a lot, but just like in terms of opportunities that exist, I think it's pretty solid. Chrome bounties. Huh. Yeah, okay. I mean, like, yes, this does exist, but I think, like, the type of compiler work that I've currently been, like, trying to hone in on is, like, middle-end work, so, like, optimizer stuff, and I think that doesn't really lend itself well to bug bounties, specifically, unfortunately. That's gonna be something that I, like, look at on the side, though. That does seem, like, interesting. Okay, let's figure out what else to do here. So we should have like a fixed list of tiles somewhere as well. We could put this in the constructor, or we could just put that as like a constant of some sort. That could be interesting. Under rapidly absorbing information, so I sometimes feel like others have that knack for just speedrunning new tech stacks. Yeah, I mean that makes sense. I feel like different, I guess like different spheres of technology, different spheres of like computer science and technology lend themselves to like different types of people just based on like, I guess the types of problems you're solving and like the types of technologies you're working with, because those also affect like a lot of other different factors. It's all pretty cool to think about. Okay. What do I want to do with this? I should make a work list, I think. Kind of self-selecting? Yeah. It's like, you don't really see a lot of like people that like consider themselves like quote unquote creative, or like everyone, like I guess in like systems you see a lot of like creative people, but like they wouldn't like self-describe themselves as like creative. They would describe themselves more as like analytical, I think, in general, compared to like maybe like front-end dev work, for instance. And like people that like really enjoy learning about one technology, I imagine, would also self-select into like more systems-y sort of work. That slash like theoretical or like people that like really enjoy learning about theory, I guess. What do you do currently for work? I go to school, so that might be where I'm at right now. I imagine the question was not directed at me, but whoops. Okay, let's make a work list. This could be a vector, actually. Node star? Node star. What am I missing? Oh. Wait. Just give it something else. Wait, What? Never understood the domain specialist type. I mean, like, it's like it's like a question of just like what brings you fulfillment, right? Like, if you enjoy like learning a lot about like one very specific like niche, then I think like it makes a lot of sense. If you're someone that just like likes to learn a lot of different things and just like, I guess if you like prefer like breadth over depth, then I can imagine that like domain depth means a lot less to you, at least. How long have you been working on compilers beyond hunting for a job? I've been doing like academic research for compiler stuff for roughly 1.5 to 2 years now, maybe. It's hard to quantify, mostly because I don't want to do the mental math. Oh, wait, yeah, okay, that makes a lot of sense. Let's give it tree here. Yeah, okay, so we have like this usual sort of structure. So we can do work list back, and then work list pop, or pop back. And then we want to, I guess, like generate code back to front almost, it feels like. That's kind of how I want to do it if I'm doing a stack, I guess. Yeah, so we want like a result sort of vector as, or I guess not vector, it'd be a list. Are you optimistic about your financial future? I'd say I'm optimistic enough. I don't think anything's guaranteed, but I think I'm primed in I think I'm in like a pretty above average spot compared to the rest of, or like compared to the average software person. In tech being highly automated exponentially. I mean, yeah, like you could probably say the same about like any other realm though. So I don't really think that affects the way I think about it a lot, at least. What type is assembly? List of unique putter of instruction. Yeah, that seems right. I guess this should be instructions, maybe? In terms of what you're studying, I didn't like focus on it because it's hard to I guess I didn't choose it because it's hard to automate, but I also think that is like a nice side effect. Like I think a lot of the work is, or at least like currently I've like talked to a couple people about like whether LLMs can like do a lot of optimization stuff, and I think it's like the general consensus is that right now it's like not particularly amazing at it, and there are some things that like will necessarily need to be deterministic. So I think in that sense, I think compilers are largely here to stay. I also think like compilers are, I guess, they also play like a sort of supportive role towards like the whole AI boom, because it turns out models are really expensive to train, and I guess really expensive to run as well. So I guess like having a mechanism for optimizing them to, I guess, work in edge environments makes a lot of sense as well. Yeah, I think that is like the large hole in LLM stuff right now. I think a lot of like the mission critical stuff just has not really existed in like the training data, so it's really hard to like tell what's gonna happen. There is like a decent line of like active research in like I guess using using LLMs to like provide compiler hints, and that's like kind of interesting to look at. But I don't. Bottom line, I don't think it is, at least for the next 10 or 20 years, going to be something that's like completely replaced. Changing NeoVim theme is a must. Okay, let's change it to something. Let's do Carbon Fox today. let's have some fun with this. Okay, so we have this stuff. Can gen the. This is try tile, I guess. Add children to work list. Let's move this around. I don't think I've ever seen you change theme. Yeah, I have like a couple sitting around here. I don't really use any of the other ones for the most part though. I just haven't had a reason to. That and also like everything on my laptop is Tokyo at Night, so there's a very strong disincentive for me to change themes at least. So we want pick largest tile. I do that. Add children to work list. I think that's all. That's kind of the whole process, right? Is there anything I'm forgetting here majorly? I don't think there's anything, at least. I think that's all we need, yeah. And then we can, like, we can do this thing, but we replace this. Let's do instructions, I think. Is this? Okay, this is not useful documentation. Let's get out of here. I'm not sure how long this stream will be. Hopefully this is like a somewhat normal length stream though. It might be like something between a quote unquote short stream for me and a standard length stream though. Was I looking up C++ lists splice? One other thought I had about the LLM pile. I think while a lot of stuff is automatable, I think at the end of the day it's still I don't think it can like completely replace the role of a programmer, in the sense that like you still need someone to I guess pilot the ship, even if it has like autopilot, right? So like what's a good example? What's like a good analogy of this? I guess like it goes to like all the LinkedIn posts by like all the grifters who are like oh there you need like you can't like, or it's like junior devs will be like replaced, everyone just needs to like become a senior dev or like someone that like designs the system. And like you might like see it a lot, but I think there's like some degree of merit to that that line of thinking at least. Started bug bounty, doing source audits, respond, transition to full time. That could be interesting, yeah. That seems pretty reasonable. I guess if you see like software engineering as just a means to an end, then like by all means that seems like a very, very secure future, and that seems like a pretty solid state to be at. For me, I feel like writing software is, I guess, about like literally writing the software and thinking through the systems. And I think that is where I derive the joy from it. So, in that sense, I don't think that would be very fulfilling work for me. Okay, splice. Okay, yeah, so it's a transfer, so we can just reuse instructions, I'm fairly sure. Okay. Would you love to create a game engine? That seems like something that'd be fun. They seem very... Like, I'm taking a game dev class right now, and it seems like there's a lot that goes into it, at least. All of the physics considerations are really interesting, and I feel like it'd be a fun challenge. It's probably not something I tackle in the near future because, well, school, but I think that could be like a fun side project at some point. Okay, now it's time to think about tiling, or like tiling in a more complex or concrete sense. I think we could just keep a list of tiles somewhere. I'm not sure what to call that though. I guess like we could just do a vector of tile. They played with LMs via APIs in any way? I haven't yet. And like that is more just like a... That is kind of just like a... me not really having too much interest in it, in the short term at least. That will definitely go on the list of things to do, but I've like, or at least I've like seen, I've like experienced people working or doing similar work secondhand in a prior internship. They were like messing with MCP servers. It seemed pretty cool, but I guess it's a little bit out of my knowledge domain at the moment, so I can't really speak more to it. High addicting. I guess that's interesting, yeah. That could be fun. I've like I guess like I kind of experienced that with like this neat little thing called vibe coding a website. So yeah, I guess I kind of understand that. Like that makes like fun, like I guess side project / hobby work for me, but I don't think it would be like, I don't think it'd be something I see myself doing like in a more permanent sense, at least. Or I guess permanent's not really the word. I guess like sustained sense. Okay. We need to define tiles eventually. We'll figure that out later. What are some good tiles we can start with? Alright, let's make one tile first. Actually, we could just define this in this file, right? We don't need that in the header per se. Yeah, this is all internal. We can easily just throw this in here, I think. Okay, we need to fix this. I guess we can do... Where do we even begin? I guess we could do load and store. Those are pretty straightforward. Alright, let's just start with load. No, let's start with store. Because store is one of the possible routes we can have here. Building a compiler? Yes, I am working on a compiler from C to x86-64. I guess what does this even need? Maybe I shouldn't define this concretely yet. Okay, that seems like a good start. I guess we can just leave that as is for now. or it's a function, or oh, this is an empty class, I see. So if we like if we add like, I don't know, just as an example, vector like int. Oh wait, no, this works. We can just make the tile, I guess, technically. Yeah, okay, we can just do an empty class for now. I love writing code, but most of my peers are mostly vibe coding. I think there's like two sides to this, right? Like, vibe coding from like a pure productivity perspective, I think is very, very efficient in a lot of contexts. But you also have to remember, I guess, like, if your goal is to learn, then I think writing code by hand makes a lot of sense. It's like, if your goal is to like strictly just output volume, I think vibe coding makes sense. But I think there's also like plenty of reasons you would want to like write code by hand. Like if you just like enjoy it more, then like fair enough. Like by all means write code by hand. It also, I think like I guess like problem domain also affects it a lot. Like if like web dev will, I guess, lend itself a lot better to vibe coding than like stuff that I guess NASA does, for instance. And also like if your goal is to like learn the theory, then I think vibe coding is, I think it's very difficult to properly learn the theory if you're just vibe coding, at least. So like, yeah. Entire mental model from prior manual coding. Yeah, of course, that makes sense. But also like, at that point, then like, that sounds like the education is gonna be like a requisite regardless, right? So like, again, my stance is from a productivity perspective, vibe coding, like, sure, fair enough. That it might have a leg up. It probably does have a leg up in most contexts. But there are also like a lot of reasons to write code by hand, at least. Okay, let's do something with tiles. Where else do I have any like class constants anywhere else, actually? I feel like I do somewhere. Actually, no, I do, but it doesn't really matter. I just like, no, that's not a thing. Oh, right, you context for functions, right. Oops. When did you start learning to code? I technically took like AP classes in, I guess there's like a lot of different starting points that you could like consider. In like elementary, I went to like a game dev summer camp, a couple times. So I think in a sense that is like my coding foundation. In another sense, you could consider like the AP classes I took in high school as when I started writing code / learning to code. And in another sense, you could consider like the start of my college CS career as I guess the start of my coding as well. Thank you so much, Exploit, for the what's it called? Super chat? I think it's whatever YouTube calls it. Thank you for the donation. This will cover how much of my tuition? Let's check the numbers. So that's $23K a quarter. This will cover roughly like 0.4% of my 0.4? 0.04 something around that magnitude of my tuition. Yeah. Yeah. Once again, thank you so much. Underrated reason why writing code by hand over using LLM is just understanding the code base. I think that makes a lot of sense. But at the same time, like, LLMs are unironically quite good at just like understanding large piles of code, at least. Even if, or I guess like it will. I feel like LLMs either give like either gives the correct answer or gives the most popular wrong answer, which is good and bad in a sense, at least. Another good mental exercise is reading design pattern and data modeling books. Yeah, that I think that is like also, that's also like a valuable exercise to do. Yeah, I think the best programmers, I think, combine a strong theoretical understanding with modern tooling in whatever capacity it is, whether it's like generative AI or like just really strong editor stuff, or ideally both. Yeah, they leverage both of them to, I guess, move really, really fast with their knowledge. Okay, I need to think about what I'm writing here. So we need a way to pick the largest tile. So we want tile in, what did I call it? Just tiles? Tiles. Do that. Yeah, I think it is just true that like LLMs are very good at just like understanding code bases, or at least understand might not be the right term. At least like being able to explain them. It's hard to like, I guess, grasp what understand means just from like a straight up like literal theoretical perspective, because like it's all linear algebra. Okay, so we want a way to match the tile. Should be a ref, maybe. What type is this? This should just be a tile, right? Okay, let's look at this type properly. I don't know, surely this is a tile type. That doesn't help me. Let's do like matches. And then we can give it like cur. Or it's like we can do covers. No, covers is wrong. Matches seems like the more precise word to use here. Yeah, I feel like changing clothes again. Let's pick another theme. We have more foxes we can use. Let's use Vig. I'm gonna take a second to cosplay Sullivan Franklin. I think that might be the play. And I will magically become slightly smarter, I guess. Okay, so if it matches, we should add matches to this list here. Or we could do like try match and return like a tuple. I'm not really sure how well that would work though. We want node star tree, I guess like root maybe. It's private. Oh, whoops. This should be virtual as well. Function is not that. Oh. Okay. Let's just, yeah, let's make this const. That seems safe. I should make a lot more things const, actually. What is wrong here now? Oh, this is const. Oh. That's really annoying. We're just gonna do this the dangerous way. Yeah, I think it's like, it's hard to quantify LLMs, I feel like. I think they are solid at like helping understand code. It's, on occasion I found it useful for like, I guess, figuring out, like, finding bugs in, like, some places. In other instances, I found them completely useless. And I think, like, I guess, like, as a pair programmer, it's pretty useful. Wanna go? Yeah, thank you so much for the donation once again. Take care and have a wonderful rest of your day. And thanks for stopping by. Okay, so we have a way to match tiles, or at least we will figure out a way to match tiles. Oh, that highlight is weird. Yeah, I also think like another interesting side effect of LLMs is that like they kind of like equalize the playing field for junior devs almost. Like, the fact that they're new is like, I guess, really interesting insofar as like a lot of older people are honestly like struggling to figure out how to use them, and like everyone is starting from zero in that sense. So I guess it's just like, it's just really crazy to think that like new grads in a sense have like a leg up for working with modern technologies, which I guess has always been the case, but like in this instance I think that could generate a disparity very, very quickly. What do you think about Rust for compilers work? I love Rust for compilers work. The only reason I'm using C++ right now is because I needed the C++ practice. If I was using Rust right now, I would have a whole lot more fun right now. Is there a way I can DNS this? I think I could just knot this and then continue. Yeah, let's do that. Let's do that, maybe. Yeah, I think, I don't know, I guess like, it's hard for me to like think of an LLM as something as like intern level, skill level at least. Like, sometimes it's really cracked, sometimes it gives a very popular wrong answer. In every instance, it's the intern that like claims to know TypeScript. In both meanings of that, I guess. Had to reorganize my windows. Okay, I think leaving things in this for loop is fine. Or what we could do is we could do largest tile, and actually, yeah, I like that more. So let's do like, what type is this? This is just tile star? Largest tile, I think we could do. Oh, this should be a putter. Yeah, and then we can just give it putters to the thing, I guess, and we will be big chilling. So we can do that, and we should add like a size function as well. Int. I guess we could do uint 64t cost. We can do get cost or something like that. We can do like tile get cost is. Oh, we need a. We should probably just track costs separately so we don't have to keep accessing it every time. Let's do uint 64t. I guess like best tile and then lowest cost. Or I guess like we could also just define cost up here, to be honest. That seems pretty reasonable as well to me. What's good, Ogre? Good to see you. Try telling LLM to generate code by name. Yeah, I think I don't know. It's a lot of interesting stuff to think about. But also like at the same time, it's also just like I don't know. Like it's really cool that any of this even works. Like if you like looked at the like transformer source paper, it's like it's just a bunch of math, and like you don't like just from like a somewhat uninformed perspective, like it's very easy to imagine that like it would do nothing or like it just wouldn't work, but it just somehow works, and it's like holy hell. A human would struggle with that too. Yeah, that's true actually. Like if you look at like the LeetCode dailies, in the in the comments, there's always like someone that's like there's always people that are like complaining about not being able to understand the problem. It's really funny. Yeah, like let's look at the daily for instance. Discussion. There's people struggling. There's people explaining how this works. I don't get Yeah, this is it's pretty funny. Let's look at. There was like a couple that I definitely got rage baited by when I was like really grinding this. I think this one. Like that example, like this example. But yeah, it's pretty funny. I think, I'm not really sure if, I think there's a chance that LLMs also hit a ceiling just because like, at some point we're just training LLMs on LLM generated code. And like, we're just gonna hit like model collapse, I fear. Okay, this should definitely still be cur. What should we call this then? I guess selected tile and like cost, I think. This will be yeah, we could get cost once here actually. It's like low or min cost actually. We should do min cost. Or I guess, how does the book explain this? What's the book called? Engineering a compiler. We'll see what it does for cost. If it's like cheapest tile or if it's like, I guess, greatest value. It doesn't matter, but I want to try to adhere to the theory. It's chapter 11, was it? Yeah, instruction selection. Okay. Let's make this readable, sorry. Oh, that is the opposite of readable. Okay, here we are. People, tree, tilings. There's like a big list somewhere. It's not this. It's not that. It's not that either. Okay, maybe it's above. Rewrite rules? Ah, cost. What companies are aiming for? I think like Quant or Big Tech. Quant needs people to work on compilers because low latency languages, something optimization, something lends itself nicely to compiler stuff. And then Big Tech because they're always funding some sort of compiler research for like their own products. So like Apple has their Swift compiler, Microsoft has like the TypeScript compiler, so on and so forth. It sucks that you essentially have to go into med school level grinds. I think it's... I disagree. I think the med school grind is just like very unironically harder, I think. Like there's just like like the sheer amount of information that you need to know for med school and the amount of effort it takes to go through med school, I think, is substantially higher than what it would take for like the average web dev. And on top of that, like if you look at like the, I guess, return, like how quickly you start making a return on like your degree, I think med school is a little bit, I guess, like delayed / deferred compared to software engineering. So there are a lot of reasons, and there's like a lot of trade-offs, unironically. Like at one point, this is gonna like sound really insane, but like if you read my website a little bit and like you know my background, you will. I'm not sure if it's on my current website, but at least my old website. I guess like, yeah, I may as well just mention it. I used to do collegiate debate, and I did like a lot of debate stuff in high school. So there was a period in time where I unironically considered going into like law as my future career path out of CS. And I was thinking like there's a lot of space for, I guess, new interesting cases to come up with like AI on the rise. But then after like a while I thought about it and I was like, law school is hard and CS is like, with a CS degree, you can literally start making money just like as a, not even as like a fresh grad, even just as an intern, honestly. You can already start paying back the return. And it's just like, it just seems like a very tough decision to justify going to law school, at least, in my opinion. And I imagine like a trade-off between a CS degree and like med school would also be similar. Vercel is the spell compiler? Yeah, exactly. There's just like a lot of random compilers all over the place that need some sort of dev work, at least. Combat surgeon, that's crazy work. Banks and lenders will offer you huge loans when you get out of med school. Based on the idea you'll make a ton of money in the future? Yeah. Unfortunately, it takes a while to pay that off. And I feel like that's just like tough business, at least from like the student perspective. Where does this talk about cost? Runtime cost. Okay, so we want to minimize cost is what I'm seeing here. So this is fine. So tile, get cost. If this is less than min cost, then we don't want to continue. And here we want selected tile equals tile, or tile ref maybe. I'll do null footer here as default. We can do -1 here actually, because that casts to UN64 max, right? No, it doesn't. Does it? Yes, it does. It does. Let's do unsigned to... No, -1 does. 2's complement. Okay. If you're... I hope a lot of y'all are familiar with like the way unsigned versus signed numbers are represented, but I think it's really cool. So I'm gonna do the explainer anyway. If you didn't know this, then like hopefully that's like something you learned from this. Okay, so unsigned numbers. So let's do like an unsigned 8-bit number. As an example here, so like we all know everyone loves binary. So let's just like draw the little grid. So we have like the 1s, the 2s, the 4s, the 8s, 16, 32, 64, and then 128. So this is like the standard representation. So let's say we want like 42 here. So if we want the representation of that, let's just convert this. So 128 doesn't fit, 64 doesn't fit, 32 fits in at once. So then we're left over with 10. 16 doesn't fit into 10. 8 does fit into 10. So then we have 2 left, so we have 0, 1, 0. So this binary representation here, this right here is 42 as an unsigned number. So negative numbers are interesting to deal with because it seems a little bit difficult to represent. So like the initial idea everyone has is just like replace one of these bits with like a signed bit. What's good, Frothy? I'm giving a little 2's complement explainer right now because it's fun. Yeah, so like everyone's first idea is to take this stuff. We can keep this the same. I'm actually just gonna rewrite this because I don't want to deal with copying. 8, 16, 32, 64. And everyone's first idea for how to represent negative numbers is just do like a plus-minus bit here. The problem with this, there's 2 big problems. The first is, well, you lose a lot of range, and that is a little bit uncomfortable. And the other thing that's like uncomfortable about this is, what is 0 here? Because let's say like 1 is negative. So if we have like 0 here, this is 0 because it's positive 0. But then you also have like negative 0, which just kind of makes me like kind of uncomfortable, and I don't really like that. So the workaround, or I guess the solution that is used nowadays for representing signed numbers is what's called 2's complement. And what they do is they take this 128 at the top, or just like the most significant bit, and they just stick a negative sign on it. And it's quite incredible actually, because so there's a lot of nice benefits here. The first, we still can just like copy paste this over into here, and we still have the representation of 42. The second thing is that I guess like negative numbers, you can just like you can kind of just like prepend you can like prepend 1s to it, and it will still represent the same negative number. So this is why 1, 1, 1, 1, 1, 1, 1, 1, with like however many 1s in front of it, will always equal -1. So like the math for this, we have -128 plus 64. That gives you -64. Add this, you get -32, -16, -8, -4, -2, and then at the end you get -1. So yeah, that's like the quick explanation. It's this flipped most significant bit that makes negative numbers work. So yeah, this means that, I guess, what's relevant for what I'm doing right now, we want the maximum possible value as the default min cost. So what we can do here, -1 is always just gonna be all 1s, or all 1 bits. So we can just throw a -1 in here and call it a day. That's the whole justification here. Hair re-dyed? Yes, that was just today actually. So that's why today's stream is a little bit later than usual. Expecting an LVM shirt by right now. I actually have a question about that. Where do I get one? Because like, I was like looking for this, and we have the bonfire merch, but like, this is like dev meeting year specific, so it's like, like this is technically it, but I was hoping there'd be just like something that's just like straight up the LLVM logo without a year attached to it at least. You don't think you studied as much as law school kids? For sure. I do. I think I have studied significantly less than a law student would have. Like, I think just like from just like a gut check sort of perspective, like you always hear about like med school, like med students and law students always like being miserable to the point where they just can't enjoy life. And like you hear that to some degree with like computer science students, but I think to a significantly smaller degree. And I'd also argue like the average computer science degree is just like kind of fluff work, honestly. Like, I think grade inflation is just very much a real thing for computer science. And it's also very easy for the average student to like, I guess, vibe code / cheat their way through a computer science education. And yeah, I think all of that combines to like, I'd argue even like a tenth of the work that someone in law school or med school would have to do. That's just like my take though. I can't like quantifiably do the math because I don't know enough about that, but that is like at least my intuition at a glance. Okay, let's update these. Let's actually undo that for tree reasons. So this is tile cost. Actually, let's rename this. Oh, what the hell did I do? Belected tile. Per tile. Yeah, that seems reasonable. What's the color scheme? Vague. It's the one Sylvan Franklin uses if you've seen his channel. Vague, and then yeah, I'm just messing around with color schemes a little today. I'm in a little bit of a colory mood. I was using Carbon Fox a little bit earlier as well. It's pretty fun. I'm enjoying this. Okay. So this selects the largest tile. We just need to implement these things. This doesn't need to be virtual. Yeah, we can do this even. Okay, yeah. So that's that part. And then here we need to just like generate the assembly, and then we need to add the residual children, I think. Yeah, this is not gonna be fun to deal with actually. Okay, I'm gonna need to think through how to do this in a more reasonable way, but I guess we can. That doesn't stop us from at least giving it a try. Sorry, I just looked at my Discord. There's an OSTEP comment blanket. That's so funny. Okay, wait. I need to send this to some people. Let me send this. Yeah, that's the book. This is too good. Wait. Okay, well. Okay, that's enough of a tangent here. Holy hell! I was not expecting to see an I was not expecting to see an OSEP throw blanket. That's so funny. Okay, let's get back on track. Even better than the Elegram shirt. I'm actually considering getting the blanket. Unironically, that'd be so funny. Okay, let's. What am I doing here? Okay, let's. We need like a. We need it to generate assembly, so we should just do this, I think. I guess. To assembly or ASM. I guess we can do that. That seems reasonable. Or we can just do like node star root. Yeah, that I like this interface. Yeah, let's splice. What happens if I splice to begin? Oh wait, no, this should be fine. So we should splice to instructions, begin. Justify putting the pointer next to the name instead of the type. I could actually justify this. Just from like a, like if you understand it as like a type, or I guess like, I could justify it both ways. So like usually when you think about it, right, you think of it as like part of the type. So like this is a tile pointer, for instance. But the reason it's better to attach this to the name here is if you're declaring multiple of these in the same, yeah, we can just like work it out of here. So if we're declaring multiple variables of the type in this one row, so let's attach it to there. So we have cur tile, this is like null putter, we have like next tile. So let's make this like, let's make like a tile up here. So we have tile temp, let's make this one. So this is like, this will be, we have this at the top, store tile. Yeah, so we have this tile temp. So we have cur tile as null pointer. Let's say next tile, we want it to be a temp a pointer to temp. So let's give it like the ref. It's like temp ref. And oh, it doesn't work. Why doesn't this work? Let's see. Let's look at the diagnostic. No viable conversion from tile star to tile. But I thought this was a tile star. So this is a tile star. This is a tile. Yeah. So the problem and the reason I attach it to the name instead of a type is because when we declare multiple, I guess, variables of the same type, the type is actually just the type without like pointer or reference. So this is necessarily, just like from an objective perspective, attached to the name. So to correct this, we need a star here, and that no longer errors. So yeah, that is something that is unintuitive if you think about it as attached to the type, at least. That's like the little spiel I have for that. I promise it's not like a stylistic thing. It is a genuine pragmatic choice. Okay, so we have instructions begin, and then we want to generate the assembly. So cur tile. Do that. Let's give it cur. Have you done any shader programming? Not any substantive shader programming, unfortunately. But I tried taking Intro to Graphics last fall, and I dropped the class. But before I dropped the class, I wrote like half of a shader, and then I gave up and then I dropped the class. Okay. So we can splice that, and then we need to add children somehow. Sierra blue now. Yeah, that's actually the lighting. It's supposed to be purple, but I guess blue is pretty funny. I'm doing well. Hopefully you're doing well as well, Bigro. What is the tile? It is, I guess this book explains it the best. Yeah, so we have like, oh, this is not really helpful. Okay, we're just gonna pull up a new drawing. And I'm so upset. I bought an iPad so I could scribble on that by hand and then like stream it to here. And then it turns out there's no good way to cast to Windows, so like my life is ruined. Okay, so tile. Let's say, I guess I'll give the whole instruction selection spiel now. So the step we're working on in the compiler, we have like our optimizer language, and we're trying to turn it into assembly of some sort. But the problem is these languages don't map one-to-one onto each other. So we need to do some shenanigans to, I guess, generate the best possible instructions that, or at least like generate better instructions than if we were to just like expand each optimizer language instruction like a macro. So let's say we have like, what's like a good example here? Let's do like int I equals like 3, and then we can do like like times equals, like let's do 4, or like let's do 8. I like 8. It'll make sense why I like 8 later. And then let's do like I plus equals 42 as an example here. So we have this like sequence of instructions. Let's assume that like this is the optimizer language. We would be doing some like SSA stuff here, but I guess no, we should do this like SSA. So int I equals 3, int j equals I times, let's draw an asterisk properly. Yeah, this is the correct way to draw it. So we have I times 8, and then int k equals j plus 42. So this is like our optimizer language. So the approach I'm taking to instruction selection is, I guess, a sort of tiling approach. So the idea is we want to take these, we want to turn them into, I guess, like, we want to turn them back into a tree representation. And then we can, I guess, quote unquote, cover the tree with tiles. So, and I'll explain why this lends to better code generation later. So, I guess first we want to generate like I guess quote unquote atomic trees for each of these instructions. So this one we have like, we assign I, we have like I here, we assign that to like 3. This one let's turn into J, and then we have a binary op, so let's do like star, if I can draw an asterisk. So then this takes I, and then this takes 8. And then next we have this K term, so let's turn this into K equals plus, and then J. Let's draw this properly. And then 42. Yeah, so this is like the first step. We've generated these 3 trees. Yeah. So then the next step is to take these trees and we want to merge them. So I'm gonna make a new page for this actually. So I guess we want to like work backwards, and there's like a bunch of rules for like whether it's safe to merge trees. I grappled more with that in like the streams where I worked on tree merging, so I'm not gonna get too much into it here. But let's ignore this poor paste. Oh, Jesus. Okay. Here we go. So we have this K node, and then we have 2 J's. We have this J here, we have this J here. It matches all of the rules. I won't get too much into it. So we can kind of overlay this tile onto here. Let's let's do a little bit of lasso select to clean this tile up a little bit. Yeah, huzzah. Okay, it overlays. So we can merge trees like this, sort of. Let's like flatten it down. And then we also have 2 I's, so we can also merge these into 1 tree. So let's copy that, let's throw this here, and huzzah. Okay, so we have this giant tree now. And the third step and the final step is, I guess, like covering the tree with tiles, which is the stuff that I'm working on right now. So I'm sorry, I have to respond to someone real quick. Okay. So yeah, next we want to cover tiles. So we have like predetermined, I guess, like tree snippets that we have defined. So like for instance, the simplest tile we have is just like this sort of assignment tile. So we have like, just for simplicity, we have 1 case here. So we have like var, and then this with a like immediate here. We can claim that this, well, let me draw in purple. I'm doing this really convolutedly. Yeah, so we can claim that this sort of tile, if we see this, we can generate like a move instruction. We can move the immediate value into var. And then like another one, let's say like var, we have like some op, we have like some sort of value here. This we can generate. We have to like be a little bit more convoluted with this, I guess. So we want to do like var, we want to move like a into var, and then we want to do like op, we want to do op b onto var as an example. So what we can do is we have these predetermined tiles. Just to make this more visually appealing, let's make this one red, let's make this one blue. So, oh yeah, this one is blue. Yeah, let's save some real estate. Let's do that. So yeah, let's start tiling. There's a lot of rules. These would ideally have like costs for the instructions. So we want to pick the one that like, I guess, has the lowest cost. Or I guess like best cost per node, I guess, sort of. There's like some heuristic. I don't remember off the top of my head. I need to grapple with that later. But yeah, so in this example, we see this tile here. So this gets covered by one blue tile. And then this here is another tile. This also gets covered by a blue tile. And notice that all these tiles will have one node of overlap. And then this last little bit we can cover with a red tile. And then using this, we can generate assembly instructions in the correct order. The reason why I like it here is because there's a certain tile that just, it covers this entire thing. It's the load effective address instruction, and that has the best efficiency out of any tile we can do here. So yeah, that's the I guess fast explanation of tree tiling, roughly. And tiles are these individual things here. What are lexers and parsers? Yeah, sorry for getting to this question so late. So I guess like they're both pertinent to the part of a compiler or an interpreter that I guess reads a source program and I guess like understands it. So what the lexer does is it reads it like, I guess, quote unquote word by word with a lack of a better explanation. And it creates words out of the program. And then what a parser does is it sort of, I guess, assigns meaning to the words. So like if we have like, for instance, int I equals 0, what the lexer would do is it would break it up into supposedly like int, then I, then equals, and then 0, for instance. Yeah. And then what the parser would do is it would take these tokens and it would give them meanings. So int, this is a type. And then it sees I. So then this is variable of type. And then it sees equals. So we're assigning something to it. And then the 0 is a 0. So what the parser would see here is it would take these tokens and it would read make a variable of type integer named I, and then we want to assign that to 0, or we want to assign 0 to that. So yeah, that's what a lexer and a parser does. Tiles could be different sizes. What algorithm computes the best one? Usually you would have like costs pre-assigned to tiles, and you're trying to optimize for cost in some way. The technically optimal way to tile a program would be dynamic programming, but it turns out that's rather slow for a lot of cases, and in practice, a greedy algorithm works pretty well. It's called Maximum Munch if you want to look it up. I think this book talks about it somewhere. I think this book is the one that like coins the term even. I could be wrong though. Munch. Okay, so I'm absolutely wrong, but is this it? Yeah. Is this it? Wait. This is the wrong chapter altogether. Okay, I might be wrong about where it lives here, but the Wikipedia article definitely mentions it, at least. Yeah. Apply to Morgan Stanley Montreal office if you're from Canada. That seems like it'd be interesting. Unfortunately, I am in the US, so yeah, unfortunate. Can you share the link to the PDF? I will not disclose how I attained this PDF, but I will mention that there are these certain shadow libraries that contain all sorts of books that you definitely should not go to procure your own copies of books. And this book is available on all of them, and I'm telling this to you complete for the sole reason of warning you to not go to these websites and refrain from downloading these. You know what to do. Anyway. Okay. Here we splice. We want to add children to the work list. I guess these classes could have static methods, right? Or functions. Yeah, of course. Okay. So how do we call this? Oh, we can do that actually. But there's not a good way to do this. Are you using a new Vim distro? No. I'm using my hand-rolled config. All my dot files should be in my GitHub, which should be in the description. Let me know if it's not. Okay. For now, I think we'll just add a get children function. So we want like, I don't know, like std vector of node star and this is get children, get leaves, I guess. It's like get remaining. This takes a node star. It feels a little bit like a code smell to pass root to all of these, at least. We could even make this a list, actually. That could be interesting. We're not like directly iterating over this. Yeah, that could be cool. Yeah, and this could also be a list then, actually. Okay. Is this virtual? This should be virtual. Oh man, I'm gonna need to implement a lot of stuff, huh? These we should default. Oh, that's really ugly. Is there a way I can make this less awful? Let's do like... I'm gonna do like an instruction list type. Why compilers? I just think they're really cool. The part that I find cool about them is that like they just combine so many interesting theoretical areas of computer science. Like you need like a strong understanding of like programming languages. You need understanding of like stuff closer to the metal, so I guess like architecture / like systems knowledge. And then like to do a lot of the work efficiently, you need to like have a strong understanding of like theoretical computer science and like algorithms. And then like it turns out compilers are like really hard to maintain because they're just giant pieces of software. They're a maintainability nightmare. So a lot of software engineering skills also go into it. Graphs, yeah. Graphs are another big instance of like theoretical knowledge being necessary. And it's just like, just the things that like these, even just like these 4 areas combine to do, I think is just like really astounding. Like it's like for instance, like some hint about like type information further up can combine with like combine with like knowledge about the hardware to like unlock performance in some like really niche area, and it's just like it seems just like very elegant to me, and I want to do a lot more work that I guess ties these sorts of areas together. Okay, so we splice onto instructions and then work list. We want to splice. Let's take work list, and this should like be a stack pretty much. And then instructions we're pushing front, which is correct. Yeah, this is the correct way to do this. Are you making it from scratch or is it LLVM based? I'm writing this from scratch, but I'm taking a lot of inspiration from LLVM. So I have my own like pass manager implementation. I've like re-implemented mem to reg from scratch. Yeah, the names are not very creative for a lot of the passes, if it wasn't obvious. Okay, I think this is like the core tree Tyler, I guess, function. This is kind of everything we need in here. So now we just need to generate a bunch of tiles, which is a little bit scary. I don't want to implement all of these things because we have virtual methods for all of this. That doesn't make me very happy. So maybe we should do like I don't know. There's probably a better way to like abstract tile, but this is like the rough outline of how we're gonna use it at least. Let's use a different color scheme. What are you making a compiler for? The end state, at least the target state for now at least, is going all the way from C down to x86-64. I'm probably not gonna deal with assembler / linker stuff because that's a whole nother can of worms, but hopefully I should be able to output an ELF binary that can be linked and then run, and then we can do some silly stuff with it from there. Let's change the color scheme again. Let's go back to my default one. Much better. I feel more at home. Anyways, let's do some committing. Rescaffold tree tile class. Okay. Yeah, I think this is probably a good state to end today's work on. Trying to think if there's anything else I want to do here. I should probably like implement at least like some of this, or like one of these. Actually, that might be smart. I should do that. Can I call you dad? Please don't. That'd make me somewhat uncomfortable. I would not recommend that personally. I guess this is technically a strategy pattern if you think about it like that. Like, yeah, that's cool. Do these need to be virtual? I don't think those need to be virtual, right? No, those need to be virtual. Of const value type. What? hell? Oh. Wait. How did I deal with like implementing functions for superclasses? I know I did this somewhere in here. Oh, it was in value. That's how I did it. What type of NeoVim are you running? What do you mean by that? I'll delete vector later. Actually, I'll delete it now. Oh, I just implement it. Okay, that makes sense. Let's... is this tmux? Yes, I'm using tmux instead of Westterm's native mux. Kickstarter? Oh, I see. I made my config completely from scratch, so I guess none of the above. Yeah, I think if I were to like recommend someone to start, and or if I were to start again, I would definitely start with Kickstart. But as it stands, everything is completely hand-rolled by me, or I guess the config is completely mine. And it uses no pre-made distro. Where the dot file's at, it should be on my GitHub. That should be linked in my description. And then it should just be pinned on my profile. Yeah, right here. Why do you prefer NeoVim? Because I prefer Lua to writing Vim script. There's not much else of a reason. Also because I use NeoVim, by the way, as a pretty funny meme. I don't have a degree, kind of land a job as a low-level programmer. I think that's very much possible. You just have to spend a lot of effort in, yeah, you just have to like take a lot of time to like actually do the learning, just like understand a lot more of the, like learn a lot of the theory by like doing a lot of reading and working on personal projects. I think that's like about all, or at least that, I think that's like the bare minimum / the floor for, I guess, landing a low-level job. You just got to put in the hours. Made the mistake of dual booting and Windows keeps blowing up my grub install. Yeah, that's not ideal. Yeah, I mean, it is what it is, I guess. There's definitely more stable ways to do it, I think, but I don't dual boot, so. But as a matter of fact, I think that's part of the reason I'm afraid to dual boot. As a C code, yeah, don't worry about asking the questions. It's good practice for me to answer them as well. This is C++. So it looks very similar, mostly because it's a superset of C, technically. But yeah, it's technically C++ code. Seems to only target x86-64. Yeah, I'm thinking about maybe adding support for other architectures. For now, at least, I want to at least get just like one complete source to assembly chain, I guess. It'd be nice if I could target other architectures as well. The big question is just like, how do I test it, and B, what would the backends for those look like? It'd also be an interesting test to see, I guess, how maintainable the code I've written has been. Okay, let's implement some of this stuff real quick. Yeah, let's make a constructor for this. Is there a reason for using std list? Yes, actually. I guess The big one is, in a lot of instances, I'm doing a lot of like inserts and deletes at iterator indices, and I want those to be constant time. In this instance, there's, I guess like the trade-off is like kind of negligible. Instructions I want to be a list for that reason, and also like I'm working with unique pointers, so I think it's a little bit cleaner to just like use lists and then splice instead of like using move all the time. For work list, I just want to use splice. There's no other reason. I'll probably like benchmark it with vector, but I don't think I'm working with programs large enough to the point where I think this will make a meaningful difference. Do you mind if I submit PRs? I'm gonna have to shut that one down, unfortunately. The goal of this project is mostly just like pedagogical for myself, so I will be working on it just literally to learn about compiler design. But also like feel free to like make a fork of it and do work on it on your own as well. I think that could be like a fun exercise on your end. Are you using one monitor? No, I've got a second monitor. That's why I'm looking in this direction when I am when I'm reading chat. What year are you in? I'm a 4th year right now. I'm finishing up my undergrad degree and starting my master's at the same time. Wish you the best of luck. Thank you. Is the project you're following? A lot of the stuff, I guess, like, I have a lot of background from, like, one of the classes I took. It was a compilers class, which I guess seems pretty obvious in retrospect, but that covered a lot of, like, the compiler front end and the compiler back end. So that's how I kind of, like, have an idea of what I'm doing. So I'm, like, not necessarily starting from zero, but I guess the main purpose of this whole project is to get me to re-implement a lot of the existing stuff in some capacity. So I'm like referencing stuff from that previous course, or like a couple of the textbooks that I have saved. What was I doing? I was implementing this stuff. That's what I was doing. Are you self-studying or doing this for a class? This is completely on my own. Do you recommend any of them? I thought it was worth learning at least. Would it be worth it for you? That's a question you'll have to answer for yourself. I think it's made writing code more fun for me at least. But like, if this isn't something that like you're like very dedicated to learning, I think it's not like strictly necessary. Like, it's important to like at least know your editor tooling, but I don't think like NeoVim specifically is significant in that regard. Do you dye your hair? Yes, I got it re-dyed today actually. How much growth do you think you've gone through? I've definitely become a lot more comfortable with, I guess, just the theory, because I've like literally re-implemented a lot of it. There's like 2 instances, I guess, that you can break this down in. The first is like, stuff that I technically did before, but I did as like part of the class projects, which were like partner based. So I didn't write a majority of the code, I guess, or at least I wrote like half the code maybe, but I definitely didn't write like a majority of it at least. So I think it's been very valuable for me at least. Just to like, I guess like get more hands-on experience implementing this stuff from scratch. The other instance is stuff that I knew about / am freshly learning about, and like I know what it like technically is supposed to look like, but I haven't gotten a chance to like actually work with it before. So I think that has also helped me a lot with just like learning about this sort of stuff and just like really understanding how it works. Would recommend learning VinMotions? Yeah, I think that's at least something that could be interesting, or at least giving it a try. If that's something that like, if you try it and like you hate it, then like fair enough, you don't need to use it. But I feel like I move a lot faster just with like Vim-based motions. What's good, Ashwin? Good to see you. How come you don't use Visual Studio or an IDE? I guess like as I've evolved as a programmer, it made more sense to like think of, I guess, to like understand my programming workflow more in terms of like the terminal, because like I'm working off a research server a lot, and then also like it's just fun, honestly. That's the main reason. I just very much enjoy using NeoVim. I just feel very fluid. Everything feels very fast. Do you have a CS degree? I'm working on getting it right now. I'm finishing up my undergrad right now and concurrently starting my master's. So it's all a good time. What debugger do you use? I guess the easiest place to look here is like my dap config stuff. I guess technically I use CodeLLDB, which is like a wrapper around LLDB that I guess lets it integrate with some form of text editor, whether it's like VS Code or NeoVim in this instance. So I guess technically I use LLDB, but I mean it's like pretty standard tooling. I don't think there's anything particularly interesting about it. Okay, we can just leave these as to-dos for now. What's wrong here though? Ah, wait, we need to define this. We need to define the constructor. Yeah, this matters actually, because we need to give it a cost. Or actually, we don't need to give it a cost. We can just actually, this is cleaner. We should do this. So this should be, how do I call super again? This is middle end mir value. Ah, I see. Okay, so we want tile. Let's give it 0 for now. Oh. Let's yank that, let's paste that. And, oh, this is still private, damn it. Okay. Let's public. There we go. Abstract class. Oh. These need to be unique pointers. Whoops. Yeah, let's make unique pointer to store tile. I say unique pointers because I don't want to, I guess, do a lot of this by hand. Or I don't want to like manage the memory by hand. That doesn't work. Oh, I need to default the destructor as well. Or virtual it. Or no, just default it, right? Right? Oh wait, oh wait. Okay, we fixed that one. Okay, we need to fix this up in a second. How do you recommend finding what domain of CS is the most interesting, because there's enough time to try everything? I think there's a lot of time to, I guess, like figure, at least like explore a lot of different areas. I think at least figuring out a genre of area could be like a good start. So like if programming languages is interesting to you, or like if systems stuff is interesting, I guess AI slash machine learning gets its whole own category, I guess. Or like if web dev is interesting. Just like there's a lot of like starter projects in each of those realms that I think can give you sort of a taste of the essence of, I guess, that area of computer science. And I think that's kind of like, yeah, I think that's probably like the best way I would recommend to go about figuring out what you like. Yeah, like I tried some AI stuff before. I had like a web dev phase. Like I made like my personal website. I wrote like a couple of Discord bots. I think like for me at least I found systems was interesting because like it requires a lot of just like deep domain specific knowledge as opposed to like understanding the technology of the week. And it also linear algebra is not my strong suit. So I very much did not like I very much did not like machine learning for that reason. Embedded, yeah, that's actually another really good area that I think would be interesting for me. I just compilers won the race there, unfortunately. Yeah, there's a lot of. It'll also like help to, I guess, like it'll help you figure out what technology you want to work with. Okay, we can definitely do something better here. The tree tiler should have, this should probably have just a list of tiles, to be honest. Yeah, let's just do this. What's wrong here? Oh, this needs to go on top? Okay. Like, okay, man. Yeah, sure. Let's put that there. Okay, so we have tiles, or we could just make this like all tiles. We definitely need to modify the constructor though. That means. Let's take that. And then we can change this. All tiles. Tails. Let's just like do this. Am I going insane? Do I need to make this separately and then push it back? Do you have a day job? I go to school. That is about as much of a day job as I think I can ask for, unfortunately. Some quarters I do a little bit of TAing stuff, I guess, or like undergrad TAing. So I guess there's like that. I guess I do technically do research as well. So I guess like those combined roughly make up a day job, I'd say. Oh, what am I looking for again? Pass manager. That's stupid. There we go. Okay, we figured that out. Wait, why was that erroring before? Am I just blind? Okay, so this still compiles somehow. So obviously this is not a problem. Oh. Oh, I couldn't have deleted that. Oh, that's not good. Okay, let's go back up. Let's go to MIR. Let's go to instruction. And this should fix everything. Did that fix everything? That did fix it. Okay, let's git commit message brah. Into robotics, firmware, and related constrained AI systems. Ooh. That seems quite cool, actually. I've never gotten a chance to understand robotics, I feel like. It's just like... It's always just like kind of fell a little bit too far into hardware land for me, unfortunately, I feel like. And I'm kind of just like out of school time to get more into the hardware side. Okay, we're gonna need to fix that real quick. This should be all tiles. This we can arrow. We can arrow this. This can be tile git. Okay, nice. Okay, well, everything seems to be fine barring like the returns, but it's about what we expected. Let's see if this builds. I hope this builds. If this builds, then I think I will be happy. Okay, well, it builds. It yells at me, but it builds. Looking more into that so I can develop Yocto stuff. Yocto. Oh, interesting. Yeah, that makes a lot of sense. Yeah, I mean, I'm still learning. That's like the whole point of this series, but like if there's any questions I can answer, feel free to ask them, and I'll give it my best shot. Okay, let's see if tests run. So that's tech faults. So they definitely don't run. I suspect it's because of these. We need to handle null pointer. Or we want to panic on null pointer. So if not cur tile, then for now we can just like return. I guess we're continue. Yeah, that seems reasonable. Here we're just gonna return default lists. Yeah, I like this. Let's just make this compile. Do you have good resources and references to learn from? Yeah, I think everyone's favorite intro, if you're not familiar with like programming languages stuff at all, is Crafting Interpreters. It's a free web book. A lot of people, I think, tend to have a good experience with it. So I'd always point that as the first place to start. The next place would probably be Writing a C Compiler by Nora Sandler. I don't remember how much it costs, but there are always places to procure books for through completely, totally 100% legal means that are definitely not shadow libraries. You know what to do. What's good, Niraj? Good to see you. Fresh cut? Yeah. That's what I spent the daytime today doing. Okay. I think this is enough scaffolding for now. The tests run. Everything builds, it looks like. What did I change here? We can just like commit more scaffolding for tree tiling stuff so it compiles. Yeah. I think with that, I think that's a pretty reasonable place to call today's stream. It's been like roughly 2 hours. Yeah, thank you all so much for tuning into today's stream, especially if you've been here for the whole 2 hours. That's a quite non-negligible amount of time. If you haven't already, make sure you sub to the channel and like the stream. It helps out a lot with the algorithm and helps get my content out to more of you. Also, while you're down there, you should join my Discord. The link should be in the description. Everyone's pretty chill. There's some pretty funny stuff in there, like the OSTEP logo blanket and an interesting line of code I wrote in the compilers channel. Yeah, and then of course down there is also my GitHub and my LinkedIn. Feel free to add me on both of those if you're curious about things like my dot files, what I'm currently up to in my career, or just any of the other projects I'm working on. Yeah, I'm gonna go get some rest and unwind now. Take care, y'all. Take it easy, and have a wonderful rest of your day wherever you are.